Okay, I am Dr. R. Srinivasan from Department of Chemistry, first year BTech. Today in this video, we will see more in water technology regarding potable water. Okay, what is potable water? Potable water is the one which is safe for drinking purposes. Okay. What are its characteristics? Potable water should have what characteristics? And what are the steps involved in the treatment of water so that water is safe and it's ready for drinking purpose? Basically, this is what they follow. The steps are what they follow in the municipal water supply. Okay. So we will continue seeing this about potable water. So water, from most of the natural resources, we know that it's not fit for drinking. So we have to be very careful nowadays because water spread a lot of diseases, and during rainy days you have to be even more cautious. So we cannot drink any water which is available. So normally we buy water which is already UV treated or RO treated, like that. So they contain different various types of impurities water. So we cannot drink any water which is available. So the water should be purified before we use. Okay. So the water which is safe for drinking purpose is called potable water. Okay. What are the characteristics of potable water? It should be clear and odorless. It should be free from disease-producing microorganisms and germs. Okay. Bacteria. It should be free from disease-producing microorganisms, germs, bacteria, and other disease-spreading things. It should be free from objectionable dissolved gases like H2S, ammonia, etc. It should be free from dissolved minerals like nitrates, nitrites, and it should be reasonably soft. Okay. And total dissolved solids should be less than 500 ppm. And another thing, it should not contain, it should be free from heavy metals like lead, chromium, okay, arsenic, fluoride, etc. They should be free from means they should be in very 10 ppm, like that. But even lead, chromium and all, it should be heavy metal, so it should be free. It should not contain even 10 ppm also. Okay. Right. So this is the introduction to potable water. Potable water means the water which is safe for drinking purpose. We call it as potable water. It should have the characteristics. It should be clear, odorless, obviously. It should be free from disease-producing germs and microorganisms. It should be free from objectionable dissolved gases like H2S, ammonia, etc. It should be free from dissolved minerals like nitrates, nitrites, etc. And it should be reasonably soft. Okay, soft means hardness causing ions. Should be like 50 ppm or within the soft region it should be. And TDS, total dissolved salts, it's very important in any water. TDS should be less than 100 ppm. TDS is nothing but total dissolved solids. Total dissolved solids, it's TDS. Okay. It's a very important parameter people check for water. Okay. This is about the introduction. Okay, steps involved in the treatment of water. So any water you cannot drink. Any water has to be treated for following steps in order to use it as potable water. Okay. So this is the steps involved in the treatment of water. This is also the municipality will treat in this way. The municipality treat water before circulation to homes. Okay. So municipal treatment of water also you can say this. Okay. Okay, what are the steps involved in the treatment of water before it is used by the people? Potable water, we know. Potable water means water which is safe for drinking and other cooking purposes. Okay. So raw water you take and it has to be screened. First step is screening, second step is sedimentation, third step is coagulation, fourth step is filtration, fifth is disinfection, and then comes potable water which is safe for drinking purpose. So without this disinfection, only up to fourth is not enough. So the disinfection is a very, very important step in addition to all this step, followed by the final step. Disinfection is very important. The first four steps are also important before disinfection. Okay. For raw water, first goes to screening. What is screening? Screening, you will have wide meshes. Meshes will be very wide. Okay. Like the particles, removal of floating materials. If the material is big enough, like dead leaves, other dead animals, or whatever it is, the water, raw water, it will get removed. Okay, that is called screening. Sedimentation, removal of insoluble impurities. Okay, sedimentation is a process like you add some chemicals, it will get sedimented. Okay, you won't add any chemicals, sorry, that is coagulant. In sedimentation, you allowed the big tank, the water is allowed to stay for 12 hours like this. Stay for 10 hours, 12 hours. Then what happens due to gravity? Okay, sedimentation occurs due to gravity. Then what you do? You remove the upper portion. We call it as supernatant. We will do, which can be separated by decantation. Okay, without disturbing the sediments, the upper portion is taken out. Removal of insoluble impurities. Next, coagulation. Settling of colloidal impurities by adding chemicals. Even by sedimentation, some impurities like colloidal impurities will stay in the water. Those things are removed actually by adding coagulants like potassium, alum. Okay. So these coagulants play a role in bringing all the small particles into a bigger flocks, and then the flocks are easily precipitates down. Then we can filter the supernatant by removing the sedimented flocculants. Okay. So filtration, then this is a very, very important step. Filtration, removal of insoluble, colloidal and bacterial impurities. It is done in layers. Okay, there will be a sand layer, gravel layer, like how under the earth crust, under the earth, the water under the earth, how it is purified by several layers. Okay, similarly here also there will be 2-3 layers. So in order to filter the insoluble, colloidal and any impurities, including bacterial impurities, some of the bacterial impurities can be filtered out. Then after this, it's a killing pathogens, destroying the organic compounds by oxidation. This is a very, very important step before the water can be used safely for drinking and other cooking processes. Okay. So we will see one by one all this step in little bit more detail. Okay, screening. Just it is water is allowed to pass through a mesh screens whereby the large floating matters or materials like leaves, wood pieces, etc. are removed. Okay. So in this, as I told, the meshes are quite like bigger. So whatever the bigger floating materials, large floating matters can get separated out by screening process. Okay. Next, sedimentation. Water is allowed to stand undisturbed for 2 to 5 hours. Stand undisturbed. Okay. In big settling tanks, suspended particles settle down due to gravity and clear water arises, which can be drawn out with the help of pumps. Okay, it's a large tank, so we can use pump to draw out the supernatant or clear water. Okay, so if you say, for example, in this beaker, this is, for example, sand and water. If you mix and allowed to settle, sand will sediment like this. The remaining portion, clear water, is above the, so we also call this as supernatant. Okay. So we can remove the clear water by decantation without disturbing the sediments. So this process is called sedimentation and decantation. This is sand and water, for example, it is shown. Okay. So any suspended particles, okay, can be separated by gravity through sedimentation process. Then the clear water which stays above the sediments can be separated out without disturbing the precipitated or sedimented particles. Okay. Okay, so this is example we have shown for separating water and sand by sedimentation process, settling, and then decantation, removing the clear one to the other beaker without disturbing the sediments. Okay. Next, coagulation. This is also a very, very important step in water treatment. Why? Because in this treatment, even small, very, very small colloidal impurities can also be separated out. Okay. Finely divided clay, silica, etc. do not settle down easily and hence cannot be removed by sedimentation. Whatever the impurities which cannot be removed by sedimentation, such impurities are removed by coagulation method. See, colloidal particles, colloidal impurities. Colloidal impurities means the particle size will be very, very, very low, in micron size. Okay, so which will not settle down that much easily. They will be with the solution. So, in order to aggregate those impurities and make them bigger flocks and make them to settle down as precipitates, we need coagulants. Okay. In this method, certain chemicals called coagulants, potash alum, potassium sulfate, aluminium sulfate dot 2H2O. Aluminium sulfate, sodium aluminate, etc. are added to water as coagulants. It gets hydrolyzed to form gelatinous precipitate. For example, NaAlO2 will form a gelatinous precipitate of aluminium hydroxide. Okay, so smaller particles together form bigger flocks. So the finely divided and colloidal impurity settles at the bottom and can be removed easily. So this gelatinous precipitate acts as a coagulant to bring all the smaller particles and form a bigger flow so that they can big enough to settle down. Okay. So another example, aluminium sulfate plus calcium carbonate, it forms aluminium hydroxide gelatinous precipitate. So we will see this coagulation and we will see diagrammatically how it is, whatever is explained, we will see how it is diagrammatically shown in the next slide. Okay, see for example, the water containing some very small impurities like colloidal impurities or impurities which cannot be separated by sedimentation process. So you add coagulant like aluminium sulfate or potassium, aluminium, potassium sulfate, aluminium sulfate dot 24H2O, alum or aluminium sulfate itself. So what if you add, what happens? The impurities get collected by the gelatinous, are collected along with the gelatinous precipitate. They forms like this. They are aggregated, slowly starting to aggregate. So when precipitate and trapped impurities, so what they will form, when different impurities get coalesced, they will become big enough to get settles down like this. See, this is coagulation. What is coagulation? Particles, the inorganic flocculants you are adding, okay, then it forms flocks, okay, like this. This is flocks, like we are showing flocks here. Now, the flocks, you can put flocculation like polymer flocculant, then all these bigger flocks will get this thing. So this is flocculation, this is coagulation. So here, these flocks are bigger enough to precipitate. So we can separate out this also by this coagulation process. Again, this is a very important one in water chemistry for treating the water in order to use it for safe drinking purposes. So flocculation is a process by which a chemical coagulant added to the water acts to facilitate bonding between particles, creating larger aggregates which are easier to separate. So the impurities come nearby and form like this, like form aggregates, and then they will settle down easily. For this flocculants, flocks, this is called flocks. We can say this portion is flock, this portion is a flock. This is a flock, like that. The method is widely used in water treatment plants and can also be applied to sample processing for monitoring applications. So this is flocculants, coagulants like potassium, aluminium sulfate are widely used in water treatment plants. Okay, next is filtration. Filtration is the most widely used method in any developing countries. One of this filtration method is sand filter. Okay, sand filter, like mimicking the nature. Colloidal matter, bacteria, microorganisms are removed. by filtration also. Then water is passed through large area sand bed. Okay. Then filter may be pressure filter or gravity filter. Okay. As the name implies, sand filters water through sand and gravel. If you see, this is sand bed, this is a gravel bed, thus mimicking nature as groundwater percolates through the ground. For example, the groundwater, it has to percolate through lot of layers. Okay, and then you get groundwater, underground water. So like that, we make several beds, sand bed, gravel bed, like that. It has to get filtered through these beds so that the water coming out is highly pure. So sand filtration. So basically, this whatever the water collected inlet, and then it passes through the sand bed and then gravel and then under drain. So this outlet, whether you can just by gravity filter or you can apply pressure for the faster filtering. Okay. Pipe used to introduce back water for cleaning the filter. This is for once this filtration process, after some time you have to clean, for that it is used. Okay. This is outlet for the pure water. Okay, this is also important step to remove any other colloidal matter, bacteria, microorganisms which can be removed by filtration can be removed. Okay. Okay. Next step is disinfection and sterilization. Okay, we have seen four steps before this, but is it enough for drinking? It is enough for the purpose of drinking? No. Why? Because this is the step which ensures that no germs or bacteria or microorganisms is present in water. This is to ensure that no germs, in short, this is spreading. Germs or bacteria or any microorganisms no microorganisms are there. So this step is the very, very important step in making the raw water into potable water. So it is very, very important step. How will you do this step? The process of destroying or killing the disease producing bacteria and microorganisms from water, make it safe, is called disinfection or sterilization. The chemicals used, are added to the water, for example, chlorine, which is used to kill the bacteria. They are called disinfectants. Chemicals used for killing the bacteria are called disinfectants. For example, chlorine is a good disinfectant. Water can be sterilized by following methods. Boiling. Boiling is a very, very general, small scale thing in our normal home purpose. If any boiled water, if you drink, it is safe. But if you want to, for the whole township, you want to supply water, you cannot boil and supply. So you need a robust system to treat. That is what this treatment is about. 5 steps. Okay. Concluded by this 5th step, disinfection or sterilization. Then chlorination, either by adding bleaching powder, amine, chloramine, or chlorination, direct chlorination. Disinfection by ozone is also there. So we will see more detailed disinfection sterilization step in the next video. So with this, we will finish this video.
Like, share and subscribe. Hit the bell icon for more updates.